be talking about the arcs of our circles and how to find their degree measure. Okay? Alright, so first of all, your arc measure is going to come directly from the central angles measure. Okay? So a central angle is an angle whose vertex is at the center of a circle. So here would be point B. So that's where your angle is going to come from. So like the lines that come from it, here to here. This would be a central angle. Okay? All right. The sum of the measures of the central angle of a circle with no interior points in common is 360 degrees. So you guys already knew that. What they're saying is if you have a circle with a center B and it's not cut into any pieces, all the way around is 360 degrees. Okay? All right, a central angle separates a circle into two arcs. So it's going to split it into more than just that one big circle. Okay? So you can have different types of arcs. Okay, the first type you might have is a minor arc. This is going to have a measure less than 180 degrees. Measures less than 180 degrees. It is going to be represented by two endpoints. Okay, and remember your endpoints are just letters, right? So like A and C would be points that you could be referring to, okay? So an example of a minor arc might be something like from the point A to the point C. We can visually see on this circle that that is less than half the circle, therefore it's less than 180 degrees, right? So if you were to name that arc, you would use the 2 points that you went to and from, so A and C, and you put a little arc above the letters. Okay? So when you're talking about a minor arc, you're just going to use the 2 letters that you started from and end up at. Okay? Just like this. Okay. So if a minor arc is 180 or is less than 180 degrees, what do you guys think a major arc has to measure? More than 180, but no more than 360, right? Can't be more than what the actual circle is. So this one is going to be between 180 and 360. Okay? This one is going to be represented with 3 endpoints to name it. Okay? So an example of a major arc might be from A all the way to C, but the other direction, right? That's the reason that we name these with 3 letters instead of 2, because if I said the arc AC, you're going to assume I meant from here to here, right? So if I add in an extra letter that's on that other side, you'll know that I want you to go the other way. So you could name this arc ADC. Okay, so that way you know which direction you're supposed to be going to measure. So an example here would be arc ADC, and you still put the little arc above your letters. Okay? And then we have a semicircle, which is going to measure how many degrees? Exactly 180, right? Because it's half of a circle. So it measures exactly 180 degrees. This one is also represented with 3 endpoints. Okay. And an example of this might be this arc here. So an example would be the arc EDC, and you still put your little arc symbol above the 3 letters. Okay. All right, then it says adjacent arcs, and we're filling in the blank. Well, what if we said that adjacent means previously? Right, it's got to be right beside each other, right? So if you have adjacent arcs, that means they're right beside each other, like EA and AC, all right? So it says these have exactly 1 point in common. So adjacent arcs are right beside each other, and they're going to share 1 endpoint. Okay? All right. Then we have the arc addition postulate. And what this says is that if you had the measure of the arc PQ right here, and you add the measure of the arc QR, it's going to give you the measure of the entire arc PQR. All right. And this measure will always be in degrees if we're referring to what the central angle is measured. Okay. All right. Then it says concentric circles lie in the same plane and have the same center, but they have different radii. Okay, so you can see this is what they're talking about over here. So these both have the same center point, right? But I can see that the radius for the small circle and then the radius from the big circle, not the same. Right? However, if these 2 circles were congruent, what would that mean? What does congruent mean? They're the same size, right? Same size, same shape. If they're congruent, then they would have the same size radius, right? They'd be the exact same size. So congruent circles are circles with the same radius. Okay. All right. And then if 2 arcs of one circle have the same measure, then those arcs must be congruent arcs. And congruent arcs will have congruent arc lengths. So, in summary for this first page, what we should be taking away is that an arc has a measure which is equal to the measure of the central angle. So however many degrees the central angle is, the arc right across from it should be the same amount of degrees. Okay? An arc's degree has to fall between 0 degrees all the way up to how many degrees is the whole circle? Right. So an arc would have to fall between those measures. Okay? And like we were mentioning right here, that congruent arcs have the same arc length. An arc, besides just having a measure in degrees, will also have a length. Okay? And we'll discuss the arc's length at a later time. But what would be important for you to realize the difference is when we're talking measure, we're talking degrees, right? Okay, in a circle, you guys learned in a previous class how to find the circumference of a circle, right? Which is just the distance around it. Okay, so I might know that this is 90 degrees, which would make this arc 90 degrees, right? But this would just be a quarter of the circumference, right? So your arc length has to do with an actual measurement, how far it is from here to here, and maybe centimeters or inches or whatever type of measurement, okay? All right, so if you will flip it over onto the back. So they give us this chart over here, and they want us to find the central angle for each one of these pieces. So we're going to start right here with the 25%. Okay. Okay, well, if these are all percentages, this is 25% out of how much? Huh? 100%, right? That's what percentages are for, right? Okay, so this is 25% out of 100%, right? But we are looking for how much that is out of 360, right? So I want to know how much that is out of 360 degrees, right? Yes, somebody already said it. It should just be 90, right? Because if this is 360 degrees, a quarter of 360 is 90. Right, so x, or my central angle here, should just be 90 degrees. You can always just cross multiply and divide, right? Okay, let's go clockwise from here. So 23, again, is 23 out of 100%, and we want to know how much that is out of 360. So we cross multiply and solve. What do we get here? Good. $82.8 degrees for that central angle. All right, next piece we've got 24. So this is 24% out of 100%, and we want to know how much that is out of 360 degrees. So again, we just cross multiply and solve here. Good. Okay. All right. Then we got this smaller piece down here, 10%, which is 10% out of 100%, and we want to know how much that is out of 360. 36. Very good. All right, and then last piece, 18% out of 100% is how much out of 360? Good. All right, and remember, all of these are angle or central angle measures, so they are all telling me how many degrees that piece is, okay? So we figured out that this was a 36-degree central angle. That would mean this arc is 36 degrees, and so on, okay? All right. So if they give it to you in percentages like they did here, you can just set up the proportion, cross multiply, and solve for the missing angle. All right? Okay. Number 2 says that in circle E, the measure of angle AEN is 18, JN is the diameter, and angle JES is 90 degrees. Find the measure of each of these arcs. Okay, so angle AEN, that would be this angle right here. They said it was how many degrees? 18. So what would that mean this arc is? Okay. All right. They also told us that JN right here is a diameter, which would mean everything from here up is how many degrees? 180, and from here down is 180, okay? And then they said the angle JES, this angle here, is 90 degrees. So what's the measure of arc JS? 90 degrees. Okay. So now that we have some of this information plugged in, let's come over here, see what we can find. Well, AN, we already said the measure of arc AN was good. Okay. The arc JA. Okay, so JA would go from here to here, right? So how could we figure out its measure? 180 minus 18 leaves us with, very good. All right, and then lastly, the measure of arc JAS. Subtract the 90 from 360, okay. So it's all of this, right? And you just keep going all the way to S. Well, we know from here to here was 180. That has to be 90. It does have to be 270. Good. All right. Okay, last question. It says in circle R, the measure of angle QRS right here is 40, guys. So that would make the arc QS also 40. The measure of angle SRT right here is 90. That would make this arc 90. It says that XS and QV are both diameters. Determine if each of these is a minor, major, or semicircle, and then also tell its degree. Okay, so first they want the measure of arc XQ. Okay, so that's going to go from here to here. Well, first, is that a minor, major, or semi?
Major.
Thank you. Okay, also, they only use 2 letters, and we said that anything that's minor will only be named with 2 letters. Okay, and we can clearly see that that's less than 180 degrees, so it's got to be a minor. All right, so how would I figure out its measure? There you go. All right, then they want the measure of arc BSX. Is it major, minor, or semicircle? Major, right? We can tell just by the way they named it. Okay. So, BSX. How would I find it? $320. How do we find 320?
Is there linear?
Yeah, well, those 2 are what kind of angles? Vertical. So this must also be 40, right? And then you could just subtract, right? Okay. All right. The measure of arc QXW. What kind is that? Oh, sorry, QXV, sorry. Semicircle. Good. Which means it measures exactly. Good. All right, and then last, they want to know the measure of arc TSV. Major, good. And it's how many degrees? 10. Very good. All right. Assignment